In this video, you will learn oxidation-reduction reaction, also called the redox reaction. Redox, it comes from reduction, so taking the first three letters, and oxidation, taking the first two letters. That's why it's called redox reaction. You will see how oxidation will happen. That means how you can see an increase in oxidation number. And also you will see a reduction happening. That means a decrease in oxidation number. For example, in a combustion, here is an equation. Let's check the oxidation number for aluminum here. Aluminum here is in its elemental form, and therefore the oxidation number is 0. Let's look at it over here. Oxygen typically will have an oxidation number of -2, and since we have 3 of them, so we have to multiply that by 3. The reason we are doing that is we try to determine what the oxidation number for aluminum is. Since the net charge is 0, so now we have -6 charge over here. 2 aluminums altogether should give us a +6 in order to get the net 0 charge. And therefore, the oxidation number for aluminum over here will be +3, because 2 of them will give us 6. Here, look at this. Oxidation number of aluminum comes from 0 to 3, so it increases. When oxidation number increases, that means it is oxidized. Oxidized. Or we can say that it is going through an oxidation. So this is what happened to the aluminum. Let's check for nitrogen. As we know, nitrogen over here, NH4. So that is give us a net charge of positive. This is the ammonium cation. Since we know that hydrogen will carry a +1 charge, and therefore in this case, nitrogen will be -3. Over here, how do we get that? Because each hydrogen is positive, we have 4 of them, and therefore we must need a -3 to balance it out. So nitrogen will be -3. Over here, nitrogen is in its elemental form, and therefore it is 0. So from -3 to 0, nitrogen is also oxidized because the oxidation number increased. Okay, let's look at the other one. Let's look at chlorine over here. ClO4. This is going to carry a -1 charge, and oxygen, as we have mentioned before, it loves to have a -2, and it is -2. That is the oxidation number for oxygen, and we have 4 of them, so multiplied by 4, that is equal to -8. The net charge of this whole thing is a -1, and therefore chlorine must be +7. So over here, chlorine is +7. It is its oxidation number. If we look over here, when chlorine is not combining with oxygen or any other type of halogen, therefore it is -1. And aluminum here is +3 because we have 3 of the -1. And if we assign it this way, it will balance out. So in this case, chlorine is coming from +7 to -1. So I'm going to write it here. Chlorine because the oxidation number decreases. From positive to -1, it decreases. Therefore, it is reduced. Or we can say it is going through a reduction process. Now, if any atom or element that is going through an oxidation process, we also call it a reducing agent. When you put the agent, the word at the end, that is the opposite of what it's doing. For example, if it's oxidized, then we call it a reducing agent. When it is reduced, we call it an oxidation agent. Oxidizing agent. Okay, so in a redox reaction, there must be some element that is oxidized and other elements are reduced. Let's look at another example. And by the way, let's look at another combustion example. So combustion is for hydrocarbon. Combustion is a reaction with oxygen and produce carbon dioxide and water. For example, CH4, that is the methane gas that we use in our house. CH4 react with oxygen. This is going to give us carbon dioxide and water. Let's check and see which element is oxidized and which one is reduced. Carbon over here. Let's see. Hydrogen is combining with a nonmetal and therefore hydrogen is +1. So over here we have +1 multiplied by 4. So that is equal to +4. Since methane, CH4, is neutral and therefore the oxidation number for carbon must be -4. Let's look at oxygen. Oxygen is in its elemental form and therefore the oxidation number is 0. Let's look at this one over here, carbon dioxide. Oxygen typically would be -2, that is the oxidation number. And since there are 2 oxygen atoms over here, so it multiplied by 2 will be equal to -4. And therefore, the carbon over here should be +4 because carbon dioxide, the molecule is neutral. Let's look at here. Oxygen over here is -2. Oxygen usually is -2 and there's only 1 over here and hydrogen will be +1. So let's see which element is oxidized. That means when the oxidation number increases, it is oxidized. Let's see which one increased over here. Carbon is from -4 to +4. So carbon, the oxidation number increases and therefore carbon, it is oxidized or oxidation. Let's look at hydrogen. Hydrogen is from +1 to +1. So the oxidation number did not change. Let's look at oxygen over here. Oxygen over here, it is 0. And over here is -2. So it decreases. When it decreases, it is reduction. When an element is oxidized, that means it's also a reducing agent. When an element or atom is reduced, that means it is also an oxidizing agent. That's why oxygen usually oxidizes something else. For example, it will oxidize the iron and form the oxide. It will oxidize other type of metal to form rust, to form the corrosion. But itself, oxygen is going through a reduction. It oxidize something else. That means it makes something else oxidize, but oxygen itself is reduced. Okay, that is about combustion. So for hydrocarbon molecules going through a combustion, that means is reacting with oxygen and produce carbon dioxide and water. And with this redox reaction, it will give off heat. All right, so let's look at the other type of oxidation reduction reaction. This one, let's look at it. Copper, what is the oxidation number for copper? Since it is in its elemental form and therefore it is 0. Over here, because this is an ionic compound, and over here the copper is 2 positive because the nitrate NO3 is a -1 and we have 2. That's why it is 2 positive. So it's coming from 0 and to become 2 positive. So the oxidation number increased during this reaction. So copper, it is copper oxidation number increased. That means it's going through oxidation. Let's look at silver over here. Since the nitrate is -1 and therefore silver is +1. So silver over here is +1. And later on, when you see silver over here is in its elemental form and therefore over here it is 0. So coming from +1 to become 0, that means the oxidation number reduced. It decreased. When it decreased, what happened is silver is going through a reduction. All right, let's try some examples. Let's do some tests. Okay, let's look at this. Well, this is the one that we have seen before. What kind of reaction is this? It's a combustion because hydrocarbon is reacting with oxygen and produce carbon dioxide and water. So all the combustion reactions are a redox reaction. That means it is a oxidation reduction reaction. All right, let's look at number 10. Which is the correct balance, the reaction for the combustion of octane? That means which one is reacting with oxygen and produce carbon dioxide and water? So this one, yes, they start with C8H18. Yes, okay. React with oxygen. And by the way, you cannot just say oxygen O. Oxygen is a diatomic molecule, so it must be O2. Okay, over here, you cannot use a decimal or a fraction coefficient. It must be a whole number. So it cannot be like this, it cannot be like this. This one is the correct one. Okay, let's come back over here. And for example, let's do some exercise. What happened for this reaction? Is this an oxidation reduction reaction? I have sodium, metal, solid, plus Cl2, that is going to give me NaCl. Well, it's not balanced, so I'm going to balance it now. All right, so is this reaction a redox reaction? Let's see. Over here, sodium, it is from 0 all the way to +1, so it's oxidized. And for chlorine, it's from -1. I mean, here is 0, excuse me. It is 0 because it's in its elemental form, and chlorine is -1. So yes, this one is going through a redox reaction. So now, how about this one? AgNO3 react with NaCl and give us AgCl, a solid, precipitate out, plus sodium nitrate. So silver is from +1 to +1, no change. Sodium is from +1 to +1, no change. So there's no change in oxidation number. That means it's not a redox reaction.